Okay. So alpha particle and proton accelerated from rest by same potential. Are you able to understand or not question? Okay, you try yourself. Don't say answer. Don't say answer. You try yourself. Got answer. So here it is coming lambda alpha. Okay, very good. Very good. Alpha by proton. Alpha by proton is 1 by 2 root 2. 1 by 2 root 2. So you remember this formula, lambda equal to h by root under 2 mqv. Yes or no? And mass of alpha particle, mass of proton, you need to substitute. Charge of alpha particle, mass of proton, everything you need to know, and v will be same only. So then after 1 by 2 root 2 answer will get. What happened, ma? Okay. So you get like this. So proton, alpha particle and potential of proton all are same accelerating. So that's why same alpha right here, alpha. Same I am writing here Vp equal to V alpha. Then lambda alpha you find it is h by 2m alpha, q alpha, v alpha, and similar way you write lambda proton is h by 2mp, qp, vp. Now here lambda alpha by lambda proton. So what will come here? Now here if you see this, it will be 2mp, qp, vp by 2m alpha, q alpha, v alpha. Now if you see here, Vp and V alpha 2 cancels, so remaining is Mp by Qp by Q alpha or M alpha into Q alpha. So here square root will be there. Okay, now you have to substitute. Lambda alpha by lambda p is what coming? Now it is 4, it is Mp, keep Mp as it is. Q proton is E basically, E divided by M alpha is 4Mp, Q alpha is 2E. Okay, now if you check here, alpha by proton ratio, Mp cancels, 1 by 8, root under 1 by 8, 1 by 2 root 2, 1 by 2. Yes or no? 1 by 2. Lambda alpha by lambda proton is 1 by 2. So this is what it is coming here. So they have done same way they have done, no worries. So take lambda alpha, lambda proton and calculate, accordingly calculate. Now come to the next question. Now write Einstein's photoelectric equation. What is Einstein's photoelectric equation? K max equal to h nu minus phi naught. So this is the Einstein's photoelectric equation, right? See, here they are telling states clearly the 3 silent features observed in photoelectric effect which can be salient. Okay. Can we explain on the basis of the above equation? Some features you tell, some basic features. Tell ma. Einstein's photoelectric equation, K max is h nu minus phi naught, that is not an worry. So they are telling K max depends linearly on V. Okay. And it is independent of intensity of radiation. Okay. So V you can take stopping potential also and frequency also, no worries. Okay, anything. K max depends on frequency. Next, K max is must be positive. Listen, kinetic energy never be negative. So kinetic energy must be positive. So here h nu will be definitely greater than phi naught. Okay. Now next, greater the number of energy quanta, greater is the number of photoelectrons. So photoelectric current is proportional to intensity. Okay. So that one also you can say. See, photoelectric current was proportional to intensity, right? That explanation nobody was about to give, but Einstein gave like this. What Einstein told, now greater the number of energy quanta, greater is the number of photoelectrons. Okay, so that is the reason photoelectric current is proportional to intensity, because intensity of light is nothing but in photon picture what it is. It is energy of number of photons per unit area, per unit time, or number of photons per second. You can tell that. Okay, so that and all you remember, please. Next lesson. Question number 31. Plot a graph showing the variation of stopping potential with the frequency. Okay, for different work functions or for different materials, and on the what factor does the slope and intercept of the line depends. So this type of questions you see. Okay, you can expect 3-mark questions like this. Okay. For one metal, work function means different, means metals are different, no? For one metal means you have to do for one metal, one only graph. Here two metal telling me two metal. Okay, but remember here they told work function W1 greater than W2. So first you remember, according to Einstein's photoelectric equation, Kmx equal to h nu minus phi naught, and here this is Ev naught, stopping potential, h nu minus phi naught. Okay, phi naught, or here if W they are taken, you can take W naught also. You can take W naught here, no worries. Now next what? Now V naught is nothing but h by E nu minus W naught by E. Okay. So that means here, if I'll do the graph of V naught and frequency, my slope will be h by E. What is the slope? Now slope will be h by E. Okay, and graph will be straight line graph like this. And y intercept, what is the y intercept? Now h nu naught. Okay, this will be so W naught by E. This will be y intercept. This is your y intercept. Okay. Now next listen. So here this is your nu naught. Okay, or nu 1, you can nu naught 1 you can write nu naught 1, and this one will be nu naught 2. Nu naught 2, this is nu naught 1. Why nu naught 2? This one, this is your metal 2, this is your metal 2, this is your metal 1, metal. Okay, now all of you listen here, they are telling W1 is greater than W2. Yes or no? If W1 is greater than W2, what you can do here? Now this will be, if you see here, this intercept, here work function comes. So with this distance I'll check now, this should be W1. This should be W1 by E, and this should be W2 by E. Okay, negative intercept coming. Okay, listen, W1 is greater now, W1 by E should be greater. So this distance should be greater. Yes or no? So this metal, for metal 1, it should intercept here. Clear? And this should be nu naught 1, this should be nu naught 2. No worries. Or in another way you can understand, as your work function 1 is greater. See here, work function 1 is greater than work function 2. That means h nu naught 1 greater than h nu naught 2, and nu naught 1 greater than nu naught 2. So this one also you can understand. So nu naught 1 will be higher. So in this axis if I'll come, this will be higher, this will be lower, 2 will be lower, 1 will be higher. See, this representation only important. Which is metal 1, which is metal 2, you should represent properly. Okay, otherwise graph will become wrong. If you by mistake metal 1 here, metal 2 here, if you put mistake. Okay, so here work function is greater than work function 1 is greater than work function 2. So work function is h nu 1 greater than h nu 2. So nu naught 1 greater than nu naught 2. So in y x axis if I'll come, nu naught 1 should be greater. Okay, so metal 1, which is having more work function, that should be in the graph na, in positive x axis, like, or in horizontal axis it should be in forward direction. Okay, that's it. Now next, slope intercept of the line. So already know slope will give h by E, and intercept of the line is giving work function by E. That's it. So this is what you have to understand the graph diagram. Write equation, do the graph, and tell what is slope what is intercept of the line depend. Okay, clear or not? Hanan and all, you can do these questions. And I told you that day basic equation is this one. From here many things I can do, many things. See, okay, stopping potential, frequency graph was like coming like this. Now come to the next question. Which one? Intercept of the line. This is only intercept of the line here. This is only intercept of the line. This is y intercept. You know y equal to mx plus c, right? Here y equal to mx minus c, like that coming. So negative y intercept. These are negative y intercept. So that is basically you can tell intercept of the line depends on what? Var function by E. Var function. Okay, minus w naught by. Go. Now question 32. A proton and a deuteron accelerated for the same potential, accelerating potential. Which of the two has greater value of de Broglie wavelength and less momentum? Give reasons to justify. Proton, deuteron, two particles. You should understand. I told you proton about deuteron. I told deuteron or deuteron. Okay, proton mass is mp. Here mass is what? 2 mp. Here charge is plus e. Here charge also plus e. Both are having plus. Proton you can imagine like 1h1 and this one is what? 1h2. Okay. Now next, greater value of de Broglie wavelength. Which is having greater value of de Broglie wavelength with same accelerated potential. So accelerated potential formula to check. Lambda equal to h by 2m qv. In this formula you see here, it depends inverse proportional to mass, charge and v. So both having same charge and same potential. Both are having what? Same charge and same potential. Accelerating potential also same for both. Okay. So that's why I can take lambda is inverse proportional to root m. I can consider this. Now tell which mass is greater? Deuteron mass is greater. So deuteron wavelength will be less. So deuteron wavelength will be less. And proton will be having more wavelength as compared to deuteron. So lambda is inverse proportional to root m. So you can write as mass of deuteron is greater than mass of proton. Okay. So lambda of deuteron will be less than lambda of proton. Okay, inverse proportional. So that's it. Clear idea? No doubt? Yes or no? So particle, remember that. Next question is which is having less momentum. See, once you find wavelength, then you can find about momentum or not. So tell me what momentum formula. So lambda equal to h by p. Now p equal to h by lambda. You can tell like this. So now inverse proportional. Now what I can write is lambda of proton is greater than lambda of deuteron. So what I can write? Momentum of proton less than momentum of. So very simple, right? Yes or no? And always remember the particle which is having less mass. Right. So proton less than deuteron. So now check here. So proton will have less momentum. We told right that proton will have less momentum as compared to deuteron. Proton will have less momentum. Okay. So they did it in different way. Some half mv square kinetic energy qv, and they substituted this and all. They are checking here. If mass same, charge same, charge same, potential same, then p is direct proportional to root m. Then proton will have less momentum. This is a different way they told. No worries. Okay. Now question number 33. A proton and alpha particle are accelerated. Proton and alpha particle are accelerated through the same potential. So potential is same. Which one of the two has greater value of de Broglie wavelength and less kinetic energy? See, this is a different type question. Particle only changed and less kinetic energy you have to tell. Less kinetic energy, that is changed. So now check here, 1, 2 particles, proton and alpha particle. So already I told about proton and alpha particle. Again also I'll tell. Proton is mass mp, charge is plus e. Alpha particle is 4 mp plus 2e. Next listen. They have same potential, both having same potential. Now which one is having greater value of de Broglie wavelength associated with it? Now all of you listen carefully. Now next listen. Same thing, lambda equal to h by 2m qv, 2m qv, root under will be there. Now lambda for proton, lambda for alpha particle, you divide and check. See here, h divided by root under 2mp into qp into vp divided by h by 2m alpha q alpha v alpha. Okay, and both accelerated potential same, so v will be same. Come, lambda p by lambda alpha, what I'll write? Now this will go up, m alpha q alpha by mp qp, because vp will get cancelled, hh cancel, 2 also cancels. Now all of you listen here. Now here mass of alpha, what is mass of alpha? 4 times mass of proton. What is charge of alpha? 2e. What is mass of proton? Here it is e. Now mp e cancel, so now what coming? Lambda proton by lambda alpha is coming root 8. So that means lambda proton is 2 root 2 lambda alpha. So that means what you understood? Proton wavelength is greater than what? Alpha particle. Okay, proton wavelength is what? Greater than, clear or not? Alpha particle wavelength. So greater value of wavelength, which is having greater value of wavelength? Proton will have greater value of wavelength. Clear ma? Proton will have greater value. So like this. So when same potential, this is the relation coming. Lambda alpha by lambda proton is 1 by 2 root 2, or lambda proton equal to 2 root 2 into lambda alpha. MCQ question can come different way. Okay, so remember this. Now next question, less kinetic energy. Which will have less kinetic energy? What will be answer? Which will have less kinetic energy? Wavelength inversely proportional. So if a proton is having more wavelength, but you can check once. See, lambda equal to h by what? 2m into ek. This is the kinetic energy relations. Now if you want to check, you can check lambda proton by lambda alpha equal to nothing but, I can write a mass of alpha into kinetic energy of alpha divided by mass of proton into kinetic energy of proton. Root will be there. Now listen. Now this one already you know, this relations. Lambda proton by lambda alpha, how much coming? 2 root 2. Okay. Root 8 is your 2 root 2, right? This value you know, this is 2 root 2. Now I have here 4 mp by mp, and here kinetic energy alpha by kinetic energy proton. See ma, you do like this, inversely proportional, but mass also matters now. Mass is there, you should consider mass also. After that you check. Now MP cancel. Root 4 is okay. Square you do both side. Square you do both side. It will come 4 root 2 equal to 4 kinetic energy of alpha divided by kinetic energy of what? Proton. Now 4 cancels. Now what you are getting from here? You are getting that kinetic energy of alpha is greater than what? Root 2 times kinetic energy of proton. Root 2 times kinetic energy of proton. Yes or no? Kinetic energy of alpha is equal coming. Semi asked out. Here root 2 square how much tell? It is 4 into 2, 8 na. So 4 into 2, so you write here. 4 cancels. Kinetic energy of alpha by kinetic energy of proton. Kinetic energy of proton equal to 2. Now alpha particle kinetic energy is 2 times proton kinetic energy. Okay, so square you take both sides and you calculate, you check that one. Okay, 2 root 2 is 8 basically, 2 square 4. Lambda equal to h by p. No, what I am saying, I am exactly getting how many times. You are telling what you know, greater or less. You are telling greater or less, right? No, listen, when 3 mark questions and all, you should explain little like this. And see, mass matters here. Mass matters. Because for both mass is different now. For both mass is same now. Whatever you are telling, that is correct. You can tell, sir, lambda is h by 2 inverse proportional to 1 by ek. I can do that. Okay. But mass is there. Number I can know now. From number I can get a proper clarity. So you can do little. 3 mark question I am telling. 1 mark, 2 mark questions now you can tell normal. So here what happening? Now your proton is having less kinetic energy. Okay. And other method also you can do, no reach. Whatever method you think that time you do. That time whatever you are thinking you do. But I am giving you clarity with number. Clear? Okay. Now 33. Now next to come 34. 34 you try to do yourself. Deuteron and alpha particle. Same way. Deuteron and alpha particle. What will be answer? First to understand the particle. Deuteron and alpha particle. So deuteron is mass of deuteron is mp 2 mp and here 4 mp. Now here charge is E, here charge is 2e. Deuteron alpha particle. Next listen. Which one has greater de Broglie wavelength? Same way. So go for lambda deuteron by lambda alpha. So what will get? Now already you know this. Lambda equal to h by 2m qv. Directly you can use this formula. Same accelerating potential. That is the reason we are taking this formula. Same accelerating potential. So directly if I will do, V will cancel. Okay, charge and mass are different. So I can write here mass of alpha into charge of alpha by mass of deuteron into charge of deuteron. Okay. Now substitute and check here. Lambda d by lambda alpha. Mass of alpha is 4 times mass of proton into q alpha is 2e and this one is 2 mp and this one is plus e. Now listen, mp cancel, e cancel, 2 cancel, root 4 equal to 2. So direct answer coming 2. Now what is your expectation answer? Deuteron wavelength will be more. So how much time coming? See here, deuteron wavelength is 2 times wavelength of alpha. Deuteron wavelength is 2 times wavelength of alpha. Are you getting or not? Detail answer. Okay, you can write yourself. No risk. What you want. So deuteron by alpha I did. So this V will cancel. 2 also will cancel. So M alpha Q alpha by MDQ. After this one, they are asking what? So greater wavelength deuteron. So greater wavelength you write here. Deuteron having greater wavelength. Next, less kinetic energy. So for less kinetic energy, again you go this formula go. Lambda equal to H by 2m Ek. Now, if I will do similarly way, lambda d by lambda alpha directly, H and 2 will cancel. So m alpha into Ek alpha by md Ekd. Root under will be there. Now what you do? Only lambda d by lambda alpha you know. This is 2. This is coming 2. Now m alpha is 4 times mass of proton. This is mass of deuteron is 2 times mass of proton. Now next what will happen here? Ek alpha by Ekd. Now take square, take both side. We'll take square both side. What will get? So your 4 equal to 2. 2 and 4 cancel. Now kinetic energy of alpha divided by kinetic energy of deuteron. Now what you do? 2 and 4 cancel 2. So you can understand kinetic energy of alpha is 2 times kinetic energy of deuteron. Kinetic energy of deuteron. Check carefully. So whose kinetic energy is more? Alpha kinetic energy more, deuteron kinetic energy less. Huh? Okay. So the lesser kinetic energy, so deuteron having lesser kinetic. 3 months. 1.5, 1.5. This one. No, only experimental setup. Draw the experimental setup, na just draw. Suppose they are asking to tell some construction working like that, explain about photoelectric effect, then little construction working you write. That's it with the setup. Tell ma what happened? Tell where doubt. You take square both side. This will become 4. Here it will be 2. 2 4 cancel 2 only. Now k alpha by k. Clear? Huh? So number you are getting. Number will not never tell you any mistakes. Number will give you correct. Okay. Now a monochromatic light frequency is given. The power emitted. Estimate the number of photons emitted per second on an average by the source. Okay. So already formula given to you. So number emitted. Number I question. Number of photons n by t equal to power by energy of each photon. This formula remember. Energy of each photon. Each photon means one photon. Each photon. So this n equal to basically we can write p by h nu. P by h nu. This formula remember or not? Already in exercise problem we did. So this question you check correctly. If a frequency is given, okay, then you find estimate the number of photoelectrons per second. So direct calculation you do. So power what given? Now 2 into 10 to the power minus 3. In exercise question you did this. 2 into 10 to the power minus 3 watt. H value to put 6.63 into 10 to the power minus 34 and this value is 6 into 10 to the power 14. Okay, now multiply and all. Now write here 5 into 10 to the power 15. 5 into 10 to the power 15. Clear? Calculation check. Now second part what telling? Draw a plot showing the variation of photoelectric current versus intensity of incident radiation on a given photosensitive surface. So you draw the current and the intensity graph. Yes or no? Which graph you tell? Second eye, which graph? Which graph? How the graph nature? Remember? Which graph tell? First, huh? Straight on. Which graph? Now the graph, which one? Experimental study. First graph was given, that graph. Okay. So photo current taken, intensity taken, they will be directly proportional. Okay. So this graph, what is the explanation according to Einstein? Explanation is whatever energy coming per second, that is basically intensity. So greater the quantum energy, greater the intensity is, greater the photocurrent. Number of emitted electrons will be more. That is the explanation. Okay. This question you check. This is a very important question. You remember, everyone. Okay. They are telling two monochromatic radiations, frequency nu1 and nu2 having same intensity, incident on a photosensitive surface to cause photoelectric emission. Explain giving reason in which case more number of electrons will be emitted. More number of electrons will be emitted. In which case more number of electrons will be emitted. And maximum kinetic energy of the emitted photoelectrons will be more. Two cases they are asking. First, understand question properly. Two monochromatic radiation, different frequency nu1 and nu2 having same intensity. They both have same intensity. Same intensity. Both have same intensity. Okay. Now what they are asking next? They are incident on a photosensitive surface. Give reason in which case more number of electrons will be emitted. Okay. More number of electrons emitted. Now for both the cases, that means I1 and I2, for both the cases intensity is same. Tell me what is intensity? Intensity is basically energy per unit area per unit time, right? Yes or no? So suppose the incident per unit area per unit time, then this energy nothing but it is basically N1 or N1 and H nu 1. That is equal to N2 into H nu 2. N2 into H nu 2. Now see, H cancels, AT cancel. Now N1 nu 1 is equal to what basically? N2 nu 2. If N1 nu 1 equal to N2 nu 2, that means N is inverse proportional to what? Nu. If this condition is coming in maths or physics, what you know? If this condition is coming, N is inverse proportional to what? Nu. So which is having more frequency? Which is having more frequency, that will have less number. Less number. Okay. So number of electrons emitted for frequency nu 2 will be more because its frequency is less. So from here you are understanding N is inverse proportional to frequency. So as, or you write here, as nu 1 greater than nu 2, N2 will be greater than N1. N2 will be greater than. Okay, so number of electrons emitted for monochromatic radiation of frequency nu 2 will be more than that of frequency nu 1. Okay, so this language you write. If you write this and all, only 1.5 mark we can give. Okay, so this language should be there and everything should be clear like this. Okay, everything should be clear like this. Next question, what they are asking? Maximum kinetic energy of the emitted photoelectron will be more. So which case maximum energy of photo emitted electrons, maximum kinetic energy. So K max will be more in which case? So two monochromatic radiation nu 1 nu 2 given. Okay. So work function will be same because on a certain one A photosensitive surface means same photosensitive surface. Work function will be same. nu1, nu2. For higher frequency, you remember this equation, Einstein's potentiometer equation. Okay, h nu equal to phi naught plus k max, that also you can write. So if a frequency, this one is not going to change. If nu1 is greater, then kinetic energy will be. Okay, so that way you can understand. So tell me, for which case? For which case? For frequency 1. As frequency 1 is greater than frequency 2, then k max increases with the frequency. That's it. This will be answer. Okay. Theoretical question with the basic maths, remember. Clear all of you? Boys, this question okay? Understood? N1 h nu1 equal to N2 h nu2. Okay. So number of photo emitters emitted per second is inverse proportional to frequency. Like that also you can. Next. Subjected to condition there. Intensity is same. If intensity is same, this thing is happening. This one you remember. Intensity is same only, this process is happening. Next question. X-ray falls on a photosensitive surface to cause photo emission. Assuming work function surface cannot be neglected, find the relation between de Broglie wavelength of electron emitted to the energy of incident photon, and draw the nature of the graph also. You check this question, all of you. You check.